Okay, some of you are already doing E here, but I'll show you what to do with E. So quotient rule, derivative of the top is 1/2 x to the negative 1/2 times the bottom, x squared plus 1, minus the top, x to the 1/2, times the derivative of the bottom, which is 2x, all over the bottom squared. That's your first step. If the question says differentiate, do not simplify, then you're done. If it says differentiate and do not simplify, you can stop. If it says differentiate, you need to simplify. Okay? Yeah. So you're going to simplify. Okay, so what we need to do is just basically multiply this, combine like terms and all that sort of stuff. Okay, so this is 1/2. And if you're multiplying same bases, you add the exponents. So negative 1/2 plus 2 is what? Yep, x to the positive 3 over 2 plus 1/2 x to the negative 1/2 minus 2x to the power of 3 over 2 here. Okay, do we have any like terms up here in the top there now? We do. We have the 3 over 2 terms right here. See this one, this one? See that? So we can subtract those. So what's 1/2 minus 2? Negative 3 over 2.
This is Sims. Please call
X to the 3 over 2.
Sims, please call 220.
Okay. So again, the biggest problem with calculus at this stage of the calculus course is not the calculus at all. It's the math, right? So it's adding, variables and exponents, right? What to do with them and how to simplify stuff. Okay. So what you could do really, right here as we simplify, you could see that there's a half that you could pull out, a 1/2, right? This is 3 times 1/2. Yep.
Oh, why is it 3 over 2?
Why is this 3 over 2? Your question? 1/2 minus 2
So 6 over
is negative
1
1/2.
4 over 2?
Yeah, so 2 is 4 over 2.
Yeah.
So 1 over 2 minus 4 over 2. That make sense? Okay. So, no, let me finish. I'll scroll up in a bit. So this 1/2 and 1/2 here, really you could pull that out. And really, right, this 1/2, when you pull the 1/2 out here, like this, and then you get rid of this, and you get rid of this, that 1/2 really is 1 over 2. Right? So the 2 goes in the bottom. So if you see that, then what you have, let me just now look at my board here. So you have on the top, you have negative 3x to the 3 over 2 plus x to the negative 1/2. And you have a 2 on the bottom here then. Does that look right? Because we pulled that half out. Okay? Now, positive exponents if possible. There's almost no end to how you could go here. So where do you stop? Again, the general rule is factor things and have positive exponents when possible. So we will take this one step further. We're going to get rid of this negative. Okay, so let's just rewrite this now. I'm just going to show you this. 3, so this is going to be root x cubed, and this is going to be plus 1 over root x. Okay, so this is big kid math here now, for sure. So how can I combine those two? I need a common denominator, right? I need a common denominator in order to combine these two. So, I know it looks a little funny there, but I need to multiply top and bottom by root x so that I have a common denominator here and here. So if I have root x all cubed and I multiply another root x, what do I have?
X squared?
I have root x all cubed. So if I multiply another root x, what do I get? X squared? X cubed? Okay, if I have root x times a root x times a root x, that's what root x cubed is, times another root x, what's that? Okay. The squares cancel out. No. If you have a square root, then it's squared. Right? Okay. So. Okay. Okay. I know what you're talking about. I know what you're talking about. This, if you view this as this is root x squared. Root x squared, right?
Yes.
And root x squared.
Oh, yeah.
Okay, so that equals x times x.
Yes.
Yeah, so this, it actually equals x squared. Okay, yeah, sorry, that's where we're getting to. Did anyone say x squared? Did you? You did? Okay. Sure you did. Okay, so we have negative 3x squared up top here, plus 1 all over, we're getting close here, all over root x, all over 2 times x squared plus 1 squared. See that? And now we're very, very close to the end, because this root x can go just down into the denominator here. And we have negative 3x squared plus 1 all over 2 root x times x squared plus 1 squared. So now we got rid of all of our negative exponents, and everything is factored, and we're simplified. Okay? Now I'm not sure if the textbook requires you to go, if the answer in the back is this exact, probably not. But no negative exponents, that's what you would do to get rid of that negative exponent. Okay, so this is the way that the answer key does it here. So again, they're using Leibniz notation, so that you'll see that. But the simplification, they don't show all the steps, but this is the same as what we got. So if you write it negative 3x squared plus 1, same as 1 minus 3x squared. Okay?